Welcome to this course on Introduction to Agroclimatology. In this first module, we will establish a strong foundation by understanding the basics of climatology, the structure and behavior of the Earth's atmosphere, and the main elements that influence our weather and climate. We will also explore how these processes are essential to agriculture. Agroclimatology is the branch of science that studies the interaction between climate and agricultural practices. This means that we are not only interested in knowing what the weather is like, but also in understanding how climatic factors such as rainfall, temperature, humidity, and wind influence the growth, development, and productivity of crops and livestock. Agriculture is one of the most climate-sensitive activities humans engage in. A small change in the timing of rainfall, an unexpected temperature drop, or a prolonged dry spell can drastically affect food production. Therefore, agroclimatology provides farmers, agricultural planners, and policymakers with the knowledge to make informed decisions. 2. Principles and scope of climatology. Climatology is the scientific study of climate, which refers to the long-term patterns of temperature, humidity, wind, precipitation, and other atmospheric conditions in a particular region. It is different from meteorology, which focuses more on short-term weather forecasting. The main principles of climatology include: climate is the result of complex interactions among various elements of the atmosphere, oceans, land surface, and living organisms. Climate patterns are influenced by both local factors, such as topography, and global systems, such as ocean currents and planetary circulation. Understanding climate requires long-term data collection and analysis to identify trends, patterns, and anomalies. The scope of climatology is vast and includes studying past climates to understand historical changes and predict future conditions. Examining the relationships between climate and natural resources. Assessing the impact of climate change on human activities, especially agriculture. Agroclimatology narrows this focus to the agricultural domain, examining how climate affects crop yield, pest and disease outbreaks, soil moisture levels, irrigation requirements, and the general timing of farm operations. 3. Elements and controls of climate and weather. To understand climate, we must first know its elements. The elements of climate are the measurable components that define the atmospheric environment. Temperature, humidity, precipitation, atmospheric pressure, wind, solar radiation. These elements are not random, they are governed by controls of climate, which are the factors that influence and determine the behavior of these elements. The major controls include: latitude affects the angle of solar radiation and thus temperature patterns. Altitude, higher altitudes are generally cooler due to the decrease in atmospheric pressure. Distance from the sea, the areas closer to oceans tend to have milder climates due to the moderating influence of water. Ocean currents, the warm and cold currents influence the temperature and humidity of coastal areas. Topography, mountain ranges can block or channel wind, affecting rainfall distribution. Vegetation cover influences temperature, humidity, and local wind patterns. Understanding these controls helps agriculturalists predict and adapt to local climate conditions. 4. Dynamics of the Earth's atmosphere. The atmosphere is a dynamic system, constantly in motion due to variations in temperature and pressure. These motions distribute heat and moisture around the globe and create the weather patterns we experience. The Earth's atmosphere is made up of layers. Troposphere, where most weather phenomena occur and where we live. Stratosphere, contains the ozone layer, which absorbs harmful ultraviolet radiation. Mesosphere, where temperatures decrease with altitude. Thermosphere, where temperatures rise again and auroras occur. In the troposphere, the uneven heating of the Earth's surface causes warm air to rise and cooler air to sink, generating vertical and horizontal movements. These movements, along with the Earth's rotation, create wind systems and influence rainfall patterns. 5. Radiation and heating of the atmospheric system. The sun is the primary source of energy for the Earth's atmosphere. Solar radiation reaches the Earth in the form of shortwave energy, which heats the land and water. The heated surface then emits long-wave radiation back into the atmosphere. Heating processes in the atmosphere include conduction, the transfer of heat through direct contact between molecules. Convection, the transfer of heat through the movement of fluids, such as rising warm air. Radiation, the transfer of energy through electromagnetic waves. These heating processes drive atmospheric circulation, create pressure differences, and power the water cycle, all of which are crucial for agriculture. 6. Atmospheric moisture. Moisture in the atmosphere exists as water vapor, clouds, and precipitation. The amount of water vapor the air can hold depends on temperature. Warmer air can hold more moisture. Humidity can be expressed in several ways. Absolute humidity, the actual amount of water vapor present in the air. Relative humidity, the ratio of current water vapor to the maximum possible at that temperature. Specific humidity, the mass of water vapor per mass of air. High humidity can increase the risk of plant diseases, while low humidity can lead to rapid water loss from plants. 7. Dynamics of pressure and wind systems. Air pressure is the weight of the atmosphere pressing down on the Earth's surface. Variations in air pressure create wind. Air moves from areas of high pressure to areas of low pressure. Global wind systems, such as the trade winds, westerlies, and polar easterlies, are created by the combination of pressure belts and the Coriolis effect from Earth's rotation. Local wind systems, such as land and sea breezes or mountain and valley winds, are important for microclimates in agricultural areas. 8. Condensation and precipitation processes. Condensation occurs when air becomes saturated and water vapor changes into liquid droplets, forming clouds or fog. Precipitation happens when these droplets grow large enough to fall to the ground as rain, snow, sleet, or hail. The main precipitation types relevant to agriculture are: rain, vital for crops but too much can cause flooding. Snow, can provide insulation for crops but also delay planting. Hail, can damage crops and livestock. Understanding the processes behind precipitation helps farmers plan irrigation schedules and choose crops suited to local rainfall patterns. 9. Seasonal variations in climate elements. Seasons are caused by the tilt of the Earth's axis and its revolution around the Sun. This leads to changes in temperature, daylight, radiation, rainfall, and evapotranspiration. Temperature affects planting and harvesting times. Daylight influences flowering and fruiting cycles in plants. Rainfall determines the growing season length. Evapotranspiration impacts irrigation needs. Farmers must align their agricultural calendars with these seasonal changes to maximize productivity. In Module 2, we'll move into the practical agricultural applications of this knowledge, covering meteorological equipment, tropical climate analysis, and the relationship between climate and agriculture, including effects on crops, livestock, irrigation, pests, and diseases.